Bohr proposed a theory for model of an atom. Then he was explained line spectrum of hydrogen. We know from the previous classes, we know line spectrum of hydrogen. Line spectrum of hydrogen has absorption spectra and emission spectra. Okay. Then he explained explanation of line spectrum of hydrogen. He explained radiation is absorbed where if electron goes from lower orbit to higher orbit. When electron goes to lower orbit to higher orbit, radiation is absorbed by the electron. Okay, where radiation is emitted. In some cases radiation is emitted if electron goes from higher orbit to lower orbit. So, change in energy in these situations is del E is equal to EF minus EI. EI means initial energy, F means final energy state. F means final energy state, EI means initial energy state. Okay. Then write down, we know the formula En is equal to minus RH by N square from the previous class. Okay, let us write here. E in place of EF, you can write down RH by NF square. Here RH by Ni square. Okay. Then what do you understand? Minus plus RH by Ni square minus RH by NF square and gives rise to RH by Ni square NF square this. Okay, you can write down. Okay. Then we know del E is equal to H nu is equal to del E by H. Okay, nu is equal to del E by H. Let us substitute it here. This one RH by H 1 by Ni square minus NF square. Okay. Frequency. Nu means frequency. Okay. Then the values you may substitute it here. RH value we know 10 to the power of 18 joules. H value 6.625 into 10 to the power of minus 34 joules. Then you may calculate. Okay, you may calculate that one. Okay. You may calculate, I think 3 point something 145 into 10 to the power of 15. I think roughly I have given the value roughly. Then Ni square by NF square. Okay, you may get this one. Then you may write this one into another way, nu bar. Okay, nu bar, we know nu bar is equal to 1 by lambda means 1 by lambda value. Okay, the relation between this one and nu bar. is, okay, we may write here, C by lambda, E is equal to C by lambda, for getting del E by HC, you can get 1 by lambda. Okay, HC. Like that, 1 by lambda is equal to del E by HC. You may write like here. Del E by HC. This is del E by H value. By multiplying, by division with C, you can get the nu bar value. Okay. Okay. Del E by HC. Del E by HC, you may write like this. Value of del E. Okay. Del E, this is the del E value, RH by HC, 1 by Ni square by 1 by Nf square. This is the way you can write down 1 by lambda. Okay. Next point. Can get RH by HC 1 by Nf square. Okay, this value we may get 109,677 Ni square Nf square centimeter inverse. In centimeter inverse, the value is 109,677 centimeter inverse. You may get that one, or in some textbook we may write like this. This is also correct. 0.9677 into 1 by Ni square Nf square meter inverse. This is also correct. Into 10 to the power of 7 into 10 to the power of 7. This value is also correct one. Okay, you may choose this one or this one, no problem. Okay. Then what he explained using this formula, what he was explained, Bohr, how he has explained spectral line spectrum of hydrogen by using this formula. Wave number 1 by lambda is equal to this one. Okay. He explained if Nf is greater than Ni, Nf is final stage, electron initial and electron at final stage. Nf is greater than Ni, then absorption of radiation occurs. Absorption of radiation occurs. Okay, absorption of radiation occurs. Okay, then del E value is positive. Del E value, change in energy is positive. Okay, absorption of radiation occurred. Okay, means it gives the absorption spectra. It gives the absorption spectra. Okay, absorption spectra. If Ni greater than Nf, it means emission of radiation takes place. Emission of radiation occurs. Then this is emission. Okay, del E is equal to negative. Here del E is equal to negative. How do we understand this concept? these two. Okay, let us take an atom. This is nucleus. Okay, this is nucleus. N is equal to 1, N is equal to 2. Okay, when electron goes to N is equal to 1 to N is equal to 2, it means final. It is final. Electron goes to initial. It is initial. Okay, this is final. Electron goes to this one to this one. That is the reason why final stage is higher value. N is equal to 2 is bigger one than compared to the N is equal to 1. So here there is a absorption takes place. Absorption, electron goes to initial to 1 to 2. Okay, this means absorption. Okay, whenever this is the absorption of radiation. This is means of absorption of radiation occurs, absorption spectra. Okay, what is this means? What is this means? Whenever initial, here in absorption starting point is here, electron goes to from this point to this point. Whereas in emission, initial is this one. Initial final stages are changes. Okay, initial point is this one. Ni is the initial from starting point of electron is here. Then final station is here. Okay, initial starting point is here, final stage is here. From electron from that one to this one, final N is equal to 2 to N is equal to 1. Here that is the reason why Ni is greater than 2, Nf is 1. Then emission takes place from this one to this one, higher level to lower level. This is known as emission takes place. On emission, energy is released. That is indicated by negative sign. That is the way you can understand these 2 points. These 2 points which are given by the NCERT textbook, you can understand like this. Electron goes to, from starting point is known as Ni. Starting point is Ni. Ending point is Nf. Okay. Here electron goes to lower energy state to higher energy state, so absorption is occurs. Here electron goes to, okay, here it is the starting point. So higher energy state to lower energy state. Here it is the initial, it is the final. So initial finals are changes from this one to this one. That is the reason why Ni is greater than Nf, then emission of energy takes place. This is, it gives the emission spectra. Here it gives the absorption spectra. It gives the emission spectra. It gives the emission spectra. How he can explain the spectral lines? Okay, there are number of spectral lines we can observe. Any line spectrum. Okay, let us take any line spectrum. There is a number of lines you can expect. You can see number of lines are expected. Okay, we saw number of lines in photographic plate. Okay, how can he explain these number of lines of hydrogen atom? He explained if you are taking hydrogen atom, there is so many hydrogen atoms. Okay, we cannot take any single hydrogen atom, we take a lot of hydrogen atoms. Okay, energy is absorbed by these hydrogen atoms. One hydrogen atom absorbs certain energy, another hydrogen atom may absorb different energy. It may absorb large amount of energy. Another hydrogen atom may absorb in very large amount of energy. You cannot say all hydrogen atoms should absorb the limited energy. So different hydrogen atoms are present in a sample. So different hydrogen atoms absorbs different energies. So that is the reason why you can get different lines Now single line, you can get different lines because our sample contains different number of atoms, different number of hydrogen atoms. Okay, those one particular atoms absorb limited energy, another particular atom absorbs greater amount, another atom may absorb different energy. So based on their absorption, you can get different lines in spectrum. Okay, in this way you can explain absorption and emission spectra by using this one. Okay, that's it. Limitations of Bohr model. Okay, limitations of Bohr model. What it means? There is some certain limitations in Bohr model. What are they? It fails to account for finer details, doublet, that is closely spaced lines of hydrogen atom. It cannot account, it cannot explain the finer details, means some lines are very close to each other. Okay, very close to each other. These are known as, normally it is known as doublet. This is known as doublet. Two lines are very close together, then we can call it as doublet. This type of details cannot be explained by Bohr theory. Bohr theory cannot explain or cannot account for the finer details. Finer details means very minute details regarding finer details regarding doublet closely spaced lines in hydrogen spectrum. Hydrogen spectrum, there is some lines are very close to each other, that is known as doublets. So this type of details cannot be explained by the Bohr theory. Bohr theory for the hydrogen atom spectrum. For the hydrogen atom spectrum. Next point. This model is also unable to explain spectrum of atom other than hydrogen atom. It can explain only spectrum of hydrogen and hydrogen-like species. Hydrogen and hydrogen-like species we know. It can explain spectrum of hydrogen and spectrum of He plus and lithium 2 plus, like that. One electron species only, it can explain the spectrums of one electron species only. It cannot explain hydrogen atom spectrum. It cannot explain the spectrum of helium atom or lithium atom because they contains more than one electron species. Helium contain 2 electrons, like that. More than one electron species, more than one electron species containing atoms given this spectrum is not explained by the this Bohr model. Okay, it can explain spectrum of one electron species. It cannot explain spectrum of more than one electron species. Okay, it cannot explain spectrum of helium, lithium, so on. But it can explain only one electron containing this ion species and this one. Okay, it should be that atom should contain, that atom or ion should contain one electron. More than one electron it cannot explain. So this is the limitation regarding the Bohr model. Next, third point. Unable to explain splitting of spectral line in presence of magnetic field is known as Zeeman effect. Splitting of spectral lines in magnetic field is known as Zeeman effect. Splitting of spectral lines in magnetic field is known as Stark effect. Okay, once again. Unable to explain splitting of spectral lines in presence of magnetic field. It cannot explain splitting of spectral lines in presence of magnetic field. In presence of magnetic field, the spectral lines undergoes splitting. That is known as Zeeman effect. Okay, this type of Zeeman effect is not explained by the Bohr theory. Bohr theory cannot explain Zeeman effect. The spectral lines, why they split in presence of magnetic field, cannot explain. Next, another type, in the spectral lines can also split in electric field also. That is known as Stark effect. it cannot explain that concept also. The Bohr theory cannot explain why spectral lines splits in electric field. Okay, these 2 points cannot be explained by Bohr theory. Okay, normally spectral lines, we know the spectral lines, this type of spectral lines, line spectrum. Okay, these spectral lines are split in presence of magnetic field. These spectral lines split in electric field. We know practically, but these are not explained by the Bohr theory. Okay, the spectral lines may split. One line may undergo several lines. Okay, this line also split into several lines. Okay, this lines in presence of magnetic and electric field is not explained by the splitting of the spectral lines in presence of magnetic and electric field not explained by the Bohr theory. Okay, this one. Next point. Okay. It could not fourth point, what it says. It could not explain the ability of atoms to form molecule by chemical bonds. Okay, it could not explain the ability of atom to form molecule by chemical bonds. Okay, it could not explain why molecules are formed from the atoms. Okay, example, hydrogen and hydrogen gives rise to H2. How it happens? It cannot explain. Okay, it could not explain ability of atom to form molecule by chemical bonds. Okay, how the elements together to form the molecule. These are the atoms, these are molecule. So it cannot explain the ability of atoms to form molecules by chemical bonds. Okay, the ability of atom to form molecules by chemical bond cannot be explained. Why the atoms converted into molecules, how the bonds are formed, this cannot be explained. Not explain the ability of atoms to form molecules by chemical bonds.